purpose of this video and future videos is to give you, the caster, information about the product you are working with. Aluminum is the most abundant metallic element in the Earth's crust, forming nearly 8% of it. Interestingly, it is one of the last metals to be cast, only starting 150 years ago. You will never see aluminum. It reacts so quickly with the air that you're actually seeing is aluminum oxide. Pure aluminum is pretty weak, but with the additions it becomes very strong. This is called the alloy. Aluminum alloy composition vary and are categorized by numbers and letters. First being the 100 series, that's an unalloyed aluminum. The 200 series is aluminum and copper alloys. The 300 series is aluminum, silicon, magnesium, and copper alloys. The 400 series is aluminum silicon alloys. The 500 series is aluminum magnesium alloys, with the 600 series currently not in use. The 700 series is an aluminum zinc alloy, and the 800 series is an aluminum tin alloy. And once again, the 900 series is currently not in use. At Batesville Products, we pour A356 strontium modified aluminum. The A stands for the alloy created from raw materials, not from recycled materials. These alloys have less impurities in them and yield better characteristics. The 356 alloy consists of silicon, 6.5 to 7.5%, copper at 0.20%, and magnesium 0.25 to 0.45%. Why silicon, copper, and magnesium? Before going over, let's go over some engineering terms. Tensile strength. Tensile strength is the ability of the casting to resist being pulled apart. Yield tensile strength is the amount of force to permanently deform the casting up to 0.2%. The ultimate tensile strength is the amount of force to make the casting break. Elongation is how much the casting deflects before it permanently deforms. Silicon, it improves the fluidity of the metal, making it flow easier into the mold. It also helps the casting resist hot tearing. This is cracks you will see in the casting when you open the mold. Silicon helps feeding the casting when it changes phases from liquid that we pour into the mold to the solid casting we take out. This is called solidification, and we will cover that in another video by itself. Copper. Copper improves the tensile strength and also improves the resistance of the casting to corrosion. Magnesium. This also improves tensile strength and the corrosion resistance of the castings. Castings with a little magnesium will also appear a little brighter in their finish. Modifiers are chemicals put into the alloy as points that silicon can attach to start growing from to make a big crystal, or what we call a casting. Modifiers help the alloy to keep it from stratifying. Stratifying is pulling apart or separating when the casting sets up. There are two main modifiers, sodium and strontium. At BPI we use strontium because it works better in a permanent mold application. Running the melt temperature high or letting the melt stand for a long time allows the strontium to burn out. We make additions as needed to have an active strontium in the melt. For safety reasons, ingots should be preheated before you put them into the melt. Also, if you analyze an ingot, you would find that the elements silicon, copper, and magnesium are stratified. This is because of the slow rate that the ingot sets up. Slower setup causes more stratification. Some ingot manufacturers extrude their product. These are not stratified. Of all the alloy choices, 356 represents a very good combination of yielding good tensile and elongation properties. There are a number of casting processes, first being sand casting, then die casting, low pressure casting, investment casting, and what we do at BPI is permanent mold casting. The speed with which the casting sets up affects the quality of the casting. Sand and investment castings set up slowly, and the alloy stratifies as it sets up, lowering its strength. Die casting sets up quickly, but the violent turbulence of the metal entering the die creates a lot of oxides, lowering the casting strength. Permanent mold and low pressure casting processes have the optimum speed of the casting setting up, yielding the highest potential of strength. Think of low pressure casting just like what we do, except the mold is mounted directly over the melting pot. Gaseous nitrogen is pressed against the melt force, forcing the metal up into the mold from the bottom. Based upon trial and error, the pressure is let off of the excess metal, which is the gate. The gate goes back into the pot. The mold is then opened up and the casting is taken out. Hydrogen and oxide films are the two biggest items that damage metal quality. While keeping hydrogen low in the metal is important of all the casting processes, the speed of the casting setting up in the permanent mold process makes it less critical than other casting processes. Oxides can be reduced by pushing back the obvious oxides on the top of the melt and inserting the ladle slowly. Pouring the metal from the ladle in a controlled stream also reduces the oxides. In pouring the metal into the mold, we pour in a controlled environment with metal coming here and the oxides flowing to the back of the ladle. Once pouring metal into the pour cup, the press tilts once it's activated, and it will slowly tilt up like this with the alloy coming this path and the oxides, just like in the ladle, forming to the back. Heat treating of 356 aluminum. Heat treating is generally done as follows. Heat the casting to a certain temperature and hold for a specific time. Once that time is up, it is immediately quenched into a 140-degree bath of water. Then you take the castings out and artificially age the castings by holding them at a certain temperature for a specific time. Our customers asked us to have their castings heat treated in different ways. These are as follows. T51. This is just an artificial aging process. If 356 aluminum is just left alone, it will get somewhat stronger. Better tensile and elongation properties are their own. T51 just makes this happen quicker. Parts with funny configurations will warp in other heat treating processes, not this one. T6 is considered a full heat treating process, using all the steps to produce the maximum strength and elongation. T7 is similar to a T6, except with longer aging processes. T7 has tensile strength lower than T6, but better elongation properties. You will see the following on the prints from our customers. They are A356F, which is no heat treating at all, and A356T51, which is what we've already discussed, well, along with the A356T6, as well as the A356T7 heat treating. The physical properties are tensile strength for A356F is 27,000, elongation at 8 inches. The A356T51 is 29,000 at 5 inches elongation, with A356T6 at 41,000 with 8-inch elongation. And lastly is A356T7, 33,000 with a 9-inch elongation.